Conduit fill calculations are essential for ensuring safe and compliant electrical installations. The National Electrical Code, or NEC, provides specific guidelines to prevent overheating and potential hazards. We'll examine these calculations, focusing on the requirements for conduit fill, protection of exposed conductors, the role of installer intent, and the general uses of conduit. The 2002 NEC specifically addresses conduit fill calculations in section 350.30. Note 2 of this section clearly states that conduit fill must not exceed 40% of the inner cross-sectional area of the conduit. This limitation is crucial to ensure adequate ventilation and prevent the buildup of heat within the conduit. However, there are exceptions to this rule. Note 9 of section 350.30 allows for a higher conduit fill of up to 60% for short sections of conduit used exclusively to protect exposed conductors from physical damage. The reasoning behind this exception is the assumption that the short conduit section does not significantly contribute to thermal insulation, thus allowing for a high fill percentage without causing overheating. It's important to understand that the NEC relies on objective criteria, primarily conductor size, conduit size, and the type of wiring method, to determine conduit fill requirements. Installer intent, or the subjective purpose for which the conduit is installed, is not considered a factor in these calculations. The code is designed to ensure safety based on measurable and verifiable parameters rather than subjective interpretations. Conduit serves several important purposes in electrical installations. Firstly, it provides mechanical protection to conductors, shielding them from physical damage, abrasion, and environmental factors. Secondly, conduit can offer a path for grounding conductors, ensuring a safe and reliable ground fault current path. Thirdly, conduit can conceal wires, improving the aesthetic appearance of installations by keeping wires organized and out of sight. Now, let's consider a specific example involving 12mm2 non-metallic sheathed cable, or NMB, within a 12-foot length of 1/2-inch Schedule 40 polyvinyl chloride, or PVC, conduit used for protection in 15 or 20 amp 120 volts residential circuits. To determine the maximum number of 12mm2 NMB cables allowed in the scenario, we need to calculate the available conduit fill area and compare it to the cross-sectional area of the cables. The unit diameter of 1/2-inch Schedule 40 PVC conduit is approximately 0.622 inches. Using this value, we can calculate the inner cross-sectional area of the conduit. Firstly, calculate the radius, which is half the diameter. Radius equals 0.622 inches divided by 2, which equals 0.311 inches. Secondly, calculate the area using the formula area equals pi times radius squared. Area equals 3.14159 times 0.311 inches squared, which approximately equals 0.303 square inches. The major outer diameter of a 12mm2 NMB cable is approximately 0.410 inches. To find the cross-sectional area of a single cable, we'll use the same formula. Area equals pi times radius squared, where radius equals 0.410 inches divided by 2, which equals 0.205 inches. Area equals 3.14159 times 0.205 inches squared, which approximately equals 0.133 square inches. Since the conduit is being used to protect exposed conductors, we can use the 60% fill allowance. To find the maximum allowable fill area, we multiply the conduit's inner cross-sectional area by 60%. 303 square inches times 0.60 equals 0.182 square inches. Now we can determine how many 12mm2 NMB cables can fit within the 60% fill limit. We divide the maximum allowable fill area by the cross-sectional area of a single cable. 182 square inches divided by 0.133 square inches approximately equals 1.37. Since we cannot install a fraction of a cable, we round down to the nearest whole number. Therefore, the maximum number of 12mm2 NMB cables allowed in a 12-foot length of 1/2-inch Schedule 40 PVC conduit is 1 cable. This ensures that we remain within the 60% fill limit, preventing overheating and maintaining a safe electrical installation. To reiterate, firstly, the inner diameter of 1/2 inch Schedule 40 PVC is approximately 0.622 inches. Secondly, the major outer diameter of a 12-2 NMB cable is approximately 0.410 inches. Thirdly, the cross-sectional area of a 12-2 NMB cable is approximately 0.133 square inches. Fourthly, the inner cross-sectional area of the conduit is approximately 0.303 square inches. Fifthly, 60% of the conduit area is 0.182 square inches. Sixthly, 1 times 0.133 square inches equals 0.133 square inches, which is less than 0.182 square inches. Therefore, up to one cable can be installed in the 1/2 inch PVC conduit without exceeding the 60% fill limit. Understanding conduit fill calculations and the NEC guidelines is essential for all electrical work. Adhering to these regulations ensures the safety and reliability of electrical systems.